Hello, my name's Philip Knight. I'm a consultant with ConsultingWhere, and this is a presentation on OGC Web Services. I'll start by introducing you to a web service. A web service is a task that is carried out by a specialist computer called a server. A client on a network makes a request to a server to ask it to carry out a specialist service. And the client does this using HTTP, or Hypertext Transfer Protocol, the standard language of the web, which you'll be familiar with from typing into the address bar in your web browser. This talk is about a specific set of web service designed by an organization called the Open Geospatial Consortium. This is a group of private, public and third sector organizations that have combined to create a specific set of specifications for how you should arrange a web service for encoding and transmitting geospatial data. OGC is all about interoperability. In the past, you had lots of software vendors that all had their own set of standards. The OGC aims to create a common set of standards to allow all services to talk to one another over the internet. This slide shows a list of OGC web services, not a definitive list, but these are the main ones. Web Map Service, WMS stands for Web Map Service. This is the OGC equivalent of Google Maps. WFS stands for Web Feature Service. This is a service that allows you to download data. WFST stands for Web Feature Transactional Service. That allows you to upload and download data. And WCS stands for Web Coverage Service, and that's to do with raster data. For a full list of OGC services and full documentation for each one, have a look at the OGC website, and you'll see there are many more than those that I've already highlighted. This slide shows the architecture of a geospatial web service. The image on the slide is taken from a really informative free course run by Penn State University. The bottom of the diagram is a database. This is where the data is stored. Next level up is the geospatial web server. This is a computer that can do the specialist mapping tasks that you need for a geospatial web service. And the next level up is a web server. That's your standard server for presenting information over the internet. And the next step up is a client. This can be a web browser, but also most desktop GIS can interact with geospatial web services. So it could be something like ArcGIS or QGIS. What is a web map service? A web map service, or a WMS, is a specification for serving georeferenced map images. When using a WMS, the client requests the server to draw a map of the specific area that is interested in. There are two ways it can draw the map. It can either draw the map on request, and this is known as a dynamically drawn map, and this means the client gets the most up-to-date data, so it is good for applications where the data is changing, for example weather data, but is also slow as the server has to process and draw each map when it gets that request in. The alternative is that you create a store of cached web tiles on the server, and when the client makes the request to the server, it already has the map for that area at that zoom level drawn, and it sends it out in response. And these are what are known as pre-rolled web tiles, and the server has a cache of these tiles already stored, and that improves the speed of the service. And this tiled web service actually has its own OGC standards, and it's known as a web map tiled service. And web map services, or tiled services, are probably the most common type of geospatial web service. Here I am demonstrating a WMS overlaid onto a tiled web map. If I reload the page, you'll see it takes some time for the WMS to download. In this case, the WMS is from the National Oceanic and Atmospheric Administration in the US, and it's showing live precipitation and temperature data, so it's good use of a dynamic web map. I'll now turn those layers off and move around the tiled base map. And you can see that those new tiles are loading at the corners and edges of the map, and that's demonstrating the tiles being downloaded from the web server. Those are pre-cached tiles, and that's a tiled web map. The next slide is about Geographic Markup Language, or GML. GML is the OGC specification for encoding geodata. Most software vendors have their own format for encoding geospatial data, and the most commonly found of these is the Esri shapefile. GML is the OGC format, and it's internationally agreed standard. GML is a type of markup language, and it's similar then to the more commonly found XML. This means that it is both human and machine readable. Here I've opened some GML in a text editor. You can see that the features attribute data is enclosed within opening and closing tags, and it's even readable. For example, you can see that this feature refers to Strickland Pond. The Web Feature Service, or WFS specification, allows clients to retrieve geospatial data in the form of GML. In fact, the GML you just saw was retrieved over the internet using WFS. WFS only allows you to read the data. You can't update or edit, but you can download it, allowing you to interact with the source data, and that's what differentiates it from WMS. As well as allowing you to get or download features, WFS also allows you to query the data. This means you can filter it based on spatial or non-spatial constraints. And so WFS allows individuals to access data, but it's also useful for machine-to-machine applications. Next, I want to demonstrate a WFS. So I've come to the USGS website, where they've got a whole load of geospatial services available. And I've found the page which has some of their WFS, or Web Feature Services. I'm just going to copy the URL for that one, which is called GeoNames. Then I'm going to go to my desktop GIS program, which in this case is QGIS, and I'm going to add that WFS as a new web feature service. Connect. It'll bring up a whole load of layers that I can look at. So let's have a look at transportation. Add that to my map, and that's going to take a little while to load. But you can see from the description box that it's loading GML data. We'll zoom in on the continental United States. Have a look at Florida. The great thing about WFS is because I've downloaded the data, I can interrogate it. So you can have a look at that one, and that's the long key viaduct. Or I can open up the attribute table behind the data, and I can see all of the data there. The other thing that we talked about that you can do with WFS is filter the data. So we'll try to do that. So we'll connect again, have a look at the different layers that are available from USGS. I'll open this box and I'll do a very simple filter. I'll look at the states and I'll select only those which are AZ. And I've already checked the attribute table and I know that that means Arizona. Okay, add that field. And you can see that the ones in green are now in the state of the ones only in the state of Arizona. And that's a useful tool for limiting the amount of data that is transported over the network. Transactional web feature services have all the functionality of WFS, but they also allow authorized users to write as well as read the database. Web applications, for example apps or GIS software, can use and combine and manage the data in a TWFS in a distributed way. TWFS allow the following operations: create a new feature, delete a feature, update a feature, and lock a feature. Lock is necessary to maintain the integrity of the database when multiple users are interacting with it. TWFS is useful because it means that you now don't have to transfer as much information over your network. So if you update information on one tree, say, remotely, you can send that one feature back to the database and it will update just that, kind of a change-only update. This is useful for low bandwidth environments, and of course TWFS can be administered to limit the authority of users to update the database. Alternatives to WFS. You probably download documents from the internet on a daily basis by clicking on links. This requires a file server, and you can request documents from it by clicking on the link. It's not dynamic. Every time you have to update the document, you also have to update the copy on the file server, and it's not possible to query it either. So you either send the whole file every time, or you have multiple copies of files on your server for the multiple use cases. The second alternative is FTP, or File Transfer Protocol. This is one of the fundamental internet protocols, along with HTTP. An FTP server has an advantage over the download link, as you can upload and download. A similar service, say, to Dropbox. It has the advantages over the download links because it allows upload as well as download, but it has most of the same disadvantages. The advantages of WFS. Most of the advantages we've already touched on. The data is machine readable, allowing app developers to get to grips with it. It also allows your server to look at the database directly, so picking up updates in real time. Properly configured, it can exchange change-only updates also. It has a high level of interoperability because it is vendor neutral, meaning it should work with all software vendors. Proprietary vendors may not have taken it up, but the open source community definitely have. So what are the drawbacks of WFS? Well, performance, unfortunately, is one of them. GML is sometimes referred to as a verbose format. It contains a lot of textual data, which means that in terms of bytes, it's one of the larger formats for encoding geospatial data, and you therefore may need substantial bandwidth. It's also not supported by all vendors. Some proprietary vendors prefer their native formats, as their GIS is tuned to perform best with these formats, and they tend to put most of their development support into their own formats, and GML has been overlooked in some cases, although it's now been much more widely supported. This is the final slide, and it's called The Real Problem, and it's about data schemas, and that's because data schemas are often the thing that gets in the way of real interoperability. Now, data schemas aren't the specification used to transfer the data, but the data themselves, not the envelope, but the letter inside the envelope. Now, that message needs to be understood at both ends. For true interoperability that allow databases to exchange data, they both have to structure and attribute the data in the same way. Now, there are generic database schemas. These are often devised by national or multinational agencies, such as national mapping agencies or the OGC themselves. And these common data schemas are designed to promote interoperability. And this is often practically the area that takes the most work and often requires a certain level of compromise. Now, finally, I just want to have a quick look at a data schema. I'm not going to go into it in any way. This is the data schema that the Ordnance Survey have devised to describe Britain's addressing database. It's structured using something called universal markup language, which we'll also not go into here, and it just shows the attributes and the relationships between the data in the database. But unfortunately, to go into it in any more depth will require an additional tutorial. So that's the end of this tutorial. So thank you for listening. And if you wish to get in touch, you can use that Twitter handle, or you can visit us at our website. And hopefully we'll have another tutorial along in due course.